Okay. How many people do we have offline there, Richard?
So here in the room, we've got six of us.
Oh, okay. Awesome.
Yeah, so we
Uh,
normally have more people, but we're sort of in the middle of sort of holiday season.
yeah, no worries.
We have this
Nice.
strange, we have a strange end of year in this country.
Yeah. Okay, so hope everyone can hear me all right. And so while this is playing, I would just say that this is actually my first time giving a talk like this, and I'm usually much more comfortable behind a keyboard than in front of a camera, so please stay with me. My name is Tuan. I'm joining from Toronto. It's about 3:30 p.m. here, which means most of you are already have a few pints in, and I'm very jealous of that. um, so this talk isn't really meant to be a deep technical breakdown of my project, though we absolutely can get into the weeds if you want to know more. What I'm really hoping is that by the end of tonight, at least one of you goes home and start a project that you've been putting off. Because the story I'm about to tell you is not about being an expert; it's about being curious enough to start and being stubborn enough to just keep going. So that thing that you just watched on the screen, I made that in my basement. I have no mechanical background, no engineering degree, and I absolutely have no idea what I was doing when I started this. And now there are about 3,000 people around the world that have built a Dune Weaver. Um, so here's the story of how that happened. It starts as many make a story do with a 3D printer. I bought a Bamboo Lab A1 printer in September 2024. Now, for a long time, I resisted getting a 3D printer just because, if you've been in the maker world for any length of time, you know what 3D printing used to be, right? It's the printer was the hobby. So you spend your weekend leveling the bed and tuning the temperature, fixing clocks, and then re-leveling the bed again. The thing you were meant to be making was almost secondary, right? And I watched that era go by and thought to myself, I wait until it will actually get good. And then Bamboo Lab came along and basically said, what is just work, right? You can just print stuff and don't have to worry about all of the technical stuff anymore. And I believe that I got one just in time. So within a few weeks, I was just printing constantly, desk organizer, wall mounts, random decorative stuff around the house. Still have a lot of them. Like this is a Korok guide from Zelda Breath of the Wild. Any Zelda fan out there? And then I have like a model of the solar system right here beside me. This is the weirdest system that can move around. Just cool decorative stuff around the house, right? And then my wife said, enough. Not the printer, but she was fine with that, but the stuff, the house was filling up with plastic objects, right? That serve no other real purpose than just being decorative. And she was right. I think so. I started to look for different projects that I can do, right? Something meaningful, something that I actually want to keep. And that's when I stumbled across the kinetic sand table kind of idea. Now, before we go any further, I need to give credit where it's due. The person who invented this was Bruce Shapiro. He founded a company called Sisyphus Industry, and he has been making kinetic sand tables since the 90s. So this is not like a new concept that I'm coming up with. The commercial tables that he and others make are generally beautiful, and like any sensible person, I wanted to get one, right? So I set out to buy a new one, and then I saw the price, right? The metal side table start around I think 1900, and it can go up really quick from there, right? So there's a custom piece on their website that go for $60,000. Uh, Now, those prices make sense for what they are, handcrafted art furniture and not consumer electronics. but I couldn't justify spending that much on a coffee table, right? And honestly, even if I did, I think there's something about building a thing yourself that changes how you relate to it, right? Um, if you buy an impulse purchase, and that sits in the corner, this is something that you spend weeks designing, and debugging, and assembling. You generally care more about it, and you will want to show it off to every person that walked through the door, right? So that was the feeling that I felt worth pursuing. So I went looking for DIY plans, and surely someone has made these before, right? And what I found was quite underwhelming. There were some plans floating around. Most require a laser cutter or CNC machine or custom woodworking. I had none of those, but I have a 3D printer and some enthusiasm. But the gap was very clear, right? A properly 3D printing friendly design with software that was actually pleasant to use didn't exist yet. So I decided to just go and build it. Um, Now I need to tell you that what that decisions actually meant in practice, right? I had never designed a physical part in my life, not even once. So I opened up Onshape is the CAD program that it's a web-based CAD program, and start to look at the blank canvas for about 20 minutes, and then I close it. Then I open it again and watch some YouTube videos for a couple of days. And my process at that point, from that point onwards, was basically, how do I create this feature, and then go and Google it, and then watch a couple of videos, try it, fail, and then try it again. And so every single features that I need, gear profile, tolerance, assembly, parametric designs, I learned it on the fly as I needed, right? Didn't do a course, didn't read a book, just had a specific problem in front of me that I figured out the minimum I needed to solve it, right? And that was when I came up with the Dune Weaver OG. It was the first design that I posted publicly, fully 3D printable with off-the-shelf electronics, and no laser cutter or CNC required. I put it on MakerWall, which is like a sharing website from Bamboo Lab, and also share on Reddit. And the response really surprised me, right? People started to build this thing almost immediately. And then photos just appear in the comment sections. Someone just made it, and do a lot of tweakings, and there's a lot of good feedback from the community, right? And that kind of told me that I have solved a real problem, and not just for myself, right? So that's the first iterations of the halfway. So this is a good segue for me to kind of get into explaining how the machine actually works. Let me stop sharing my screen so that you can see the camera better. I have one with me here. So this is the Dune Weaver Mini Pro. It's the 3D printed enclosure. There's a top that I can take off with an acrylic disc. This is the sand bed. There's LED strip around. This is a WS 285 addressable LED strip. There's a magnet ball here that can move around. There's a magnet underneath that can guide the magnet ball. I put a layer of EVA foam here to dampen the noise and smoothen out the motion. Take the things off as well. So this is the LED wiring you can take off. And underneath you have two main axes. This is the rotational axis right here, being driven by a motor. This is X, and then you have the Y axis with that can move the gear pedal in and out. And then there's a magnet that sits here. And so, basically, with this polar coordinate system, right, you can program the motor to move around with different rate, different steps, and then that will in turn create patterns on a sound bed like this. And the whole thing is driven by a Raspberry Pi. There is a DLC32 board here that control the motions of the motors. I will get more into that in a little bit. There are two NEMA 17 motors, stepper motors that can control the two axes. There are some only effect sensor here so that we can form the table as well, like one inside and one here. So that's a little bit about the Dune Weaver mechanics. So with the two axes, right? This is a little bit different from traditional Cartesian's kind of coordinates. So in a Cartesian plane, you have x and y axis that you can move independently of each other, right? So you can move x without affecting y and vice versa. Whereas in polar coordinates, so you have two values. You have theta is the angle of the rotation, and then you have rho. It's like how far is it from the center. With the design of the Dune Weaver, I should share my screen again. We'll do that in a minute. With the design of the Dune Weaver, when you move the x-axis, you can see that y also move outward or inward depending on the directions of x, right? So the two axes actually couple, just because the radial arm is it's mounted on top of the rotational of the angular gear, right? One second, let me share my screen again. Okay, so that was one of the harder challenge that I had to solve. So basically, it's hard to find firmware out there that was made for this very unique system that is open source, right? So and I didn't really have a lot of skills to go and build a firmware myself. I can code. I can do Python really well. C, a little bit less so. So that was one of the main challenge that I faced quite early on. How I solved it was instead of relying, like coming up with a custom firmware, I decided to just build basically what is called a G-code preprocessor. Meaning, the table itself will still run the Cartesian system, but the preprocessor in this case will be running on a different device, on a Raspberry Pi, and then the Pi will keep track of all of the motions, all of the coordinates, and then convert it and account for the offset of the axis coupling, right? And offset that with every motion so that we can have a precise motions in a polar space. So yeah, that was how I solved one of the first one of the earlier hardware problems. And so around the same time, my sister saw the Dune Weaver OG and loved it, and I thought I want to make her one as a gift, something a little bit smaller and cheap, so that she can put on her desk. And that was when I came up with the mini Dune Weaver. It's about 25 centimeter diameter, 10-inch, compact, square enough for a bedroom or office. It's could use different kind of motors. So this one uses this cheap stepper motors that you can get off Amazon, and the UNL 2003 motor drivers. But the BOM for this entire table is only $30, right? So for kinetic sand tables, for something that you can build and put it in the parts, this is pretty compelling for many people. So this one got quite popular as well. And so both of these plans are still available for free on MakerWall right now. And then I asked myself, right, what would a truly polished version look like? And not a maker project, something like a furniture grade, something that you would be proud to have in your living room. And so, as my CAD skill get a little bit better, I decided to build the Dune Weaver Pro. So the key insight here was that I didn't design this table from scratch, right? I designed something that fits inside a table that people already own. So the base of this table is actually from an IKEA table. So it's this IKEA coffee table that's very popular. It's about $70 Canadian. And basically I flip it around, right? I flip the frame around so I can use a crossbar at the bottom here to mount the motors. The table already came with materials that would otherwise be you would have to make a custom sauce, right? So the tray in the bottom here I use as a sand bed, and then the glass here is the glass top for the table, right? So in the end, this is the product that I came up with. Parts for the Dune Weaver Pro come in at around $250 on in, and compare that to about $3,000 for the equivalent Sister First Metal coffee table, right? And you're getting something that is furniture grade, beautiful, and can live in your living room, and you actually have the experience of building one, right? So that's been one of the things that I care about most with this project, that people should be able to build something cool and actually show it off and not hide it in garage, right? So yeah, that's the thing. One thing that I didn't fully anticipate when I started was how much people actually learn by doing this project. I hear from a lot of makers in our community is that some people who Dune Weavers are comfortable with software, but never touch hardware, right? Like wiring motors, flashing firmware, or understanding a circuit. It's all new to them. Why with other people, right? They might be comfortable with software, but like it is hard for them to figure out the hardware side, right? So I made it a goal of this project to not just give people a sand table, but also to build something that people can learn along the way, right? So as you learn the project, you can learn more about software side, the hardware side of it. So hopefully every Dune Weaver builder come out on the other side knowing something that they didn't before, right? And then as the project goes along, I create different variations of this. So this is the Dune Weaver Gold. Have it right behind me. It's also based off of an IKEA table. It's a smaller 45 centimeter table, side table. And then this is the Mini Pro. This is also an IKEA bowl. And this is the 3D printed bowl that I just showed. Right. And this is also a good segue for us to get into the software side of things. So the OG, I used the Arduino Uno with a CNC shield as the kind of the processing the microcontroller for it, right? But I was severely limited by this hardware choice. Basically, it's the Uno has a very limited memory, barely has any processing power at all, no networking, and then dealing with custom C code was a nightmare to maintain, right? And then the company key was also asking for more features of this. So that was when I decided to, try and find a different approach to this. So I redesigned the whole electronic stack, and instead of using the Uno, I decided to move forward with like a DLC33 board like this. Basically, it runs a Fluid and C firmware, which is a global-based motion control firmware. This device only job is to move the ball. So it's received the G code and driver steppers with it's received the G code and drives the stepper motors with the precisions. It's also make wiring a lot more easier as well, since this device taking 12 volt and its output 5 volt as well. So it has a built-in kind of buck converter. So I can just have one power line coming into the whole system, powering the board. And then I can use a 5 volt from this board to power the Raspberry Pi. I can use a 12 volt from here to power the LED as well. So it's very convenient for wiring. This also decided to use a Raspberry Pi to run the Dune Weaver applications, right? Because I wanted to build a web app that is feature-rich, that's just really easy for people to use, and building on top of something like an ESP32 based architecture is a lot harder than a Linux environment, right? So I decided to do a two controller kind of approach here. So the Pi connects to the DLC32 via UART. So you can also use USB for that, but the Pi will send all of the G code command via UART, and then Pi will also drive the LED, right? So we can create very beautiful LED patterns as well. So yeah, with that kind of decisions, that was able to allow me to unlock a lot of features for the projects. I can quickly show off the front end of the project. So in here, you can you have a pattern list that you can browse here. If you see a pattern that you like, you can click on it and kind of preview how it will play out on your table. We'll take a moment to load. Okay, and kind of see how the pattern will play. You have different control for how you want to clear the patterns, right? I have adaptive mode, in which it will basically try and figure out where the pattern start. So in this case, it starts from 0 row, meaning at the center, right? So when the pattern is starting from the center, we want a clear pattern from the outside so that the ball end up in the center. And then when it's go and start the pattern, there's no like cross line that won't ruin the canvas, right? So you can browse stuff, you can create a playlist here with a lot of different patterns. You can control the time between patterns that you can play. You can home the table, basic control here, control the speed. You can have a terminal here to send G-code command as well for debugging. You can control the LED, turn it on and off, have different effects, different colors and different automations as well. And then, I have tons of settings in here for people to go and play around. So it integrate with Home Assistant, for example, right? So you can start the pattern from automations, or you can turn on and off the LED when someone walk by and trigger a motion sensor. You can configure the Wi-Fi here. It can create its own hotspot when it's in the Wi, so people can go in and control it. I have still send, this mode is basically to turn off the table at midnight, so it's not playing and disturbing anyone. So yeah, a lot of features that I don't think I could have implemented if I was to just go with like a one microcontroller approach. Okay, so sorry if you hear the baby in the background. um, at some point, the project took off, and this became quite popular, and it was exciting and terrifying in equal measure. Waking up seeing dozens of messages on Discord or emails. But here's what nobody tells you when you open source something, right? This project stops being yours. And that's actually very beautiful, right? People started building Dune Weavers with mods. They create different enclosures, custom layout setup. One person actually built it into a handmade walnut table that looked really amazing. And I just stared at the forest, right? And we now have builders from in over 40 countries, thousands of people on Discord, helping each other, troubleshooting views across time zone in different languages. People who I never met, solving each other's problems and sharing photos of their views. And I realized that I didn't build that community, right? I just built the thing that gave them a reason to defy each other, which is very nice. Also want to be honest about the harder parts, right? Supporting thousands of builders when you're one person with a day job is genuinely very difficult. Sustainability is a real ongoing question for me, right? But here's the thing: is every hard problem actually arrive after I already built something real, right? The problem aside that it's actually work. And I'm still here, still active, still in Discord every day, answering questions and helping people debug their builds and shipping new features for the Dune Weaver. And there's now a business with this as well, with selling digital plans for people to go and build this. But that came later, and I could do a whole separate talk about that journey, right? But more than the business, right? What keep me going is the project is still growing. New builders every week. We have new patterns, new ideas from the community that I haven't thought of yet. So I'm genuinely excited to see where it goes. And it's not a finished thing, right? It's an ongoing one, and I'm very much still there. So to sum up, right? I started this because I had a 3D printer and a house full of clutter, and a wife who very reasonably said, build something worth keeping. I had no CAD skills, no mechanical background, no laser cutter or CNC. I didn't know Onshape. And I just had a problem to solve, right? And I wanted a sand table. I couldn't justify the cost of buying one. And I couldn't find plans that I could actually build from, right? So I figured it out one YouTube video at a time, one pre-printed part at a time, and one late night at a time, right? And I want to leave you with this. You don't need to be qualified, right? You just need to start. So the first version will more likely than not be bad, right? And that's okay. It just need to exist. And everything else, the refinement, the community, the feature, that come from building and sharing and listening to the people that who show up, right? And whatever project you've been sitting on, the one that you keep meaning to start when you have more time or better tools or more experience, don't wait for those things, right? Start them now and build the first versions and put it online, and you might be surprised who shows up, right? So yeah, thank you for inviting me. And if you're interested in building the Dune Weaver, please check out my website, duneweaver.com. I'm happy to take any questions that you might have.
Thank you very much. That was really interesting. I did have a question about the, I have lots of questions, obviously, but one of the things, how long did it take you to get from I'm just saying I want to do this to your first version that actually worked, that your wife was happy with?
It took me not too long actually. So I got the table in September of 2024. The Dune Weaver Pro actually finished and built and put the plan online in December 2024. Right, so just a couple of months to do
That's
this.
pretty good, yeah.
Yeah, but I mean the software part is actually the one that took a lot of time and a lot of iterations to get to this point. Um, and a lot of help from the community contributing ideas and contributing to the code base as well. Although the the code base was like something like 95% was done by me, so still a lot of work. Yeah.
So with the speed of the ball that rolls, can you modify that, or is it constant speed, or is it just at some speed it just stops working, or what, how does that work?
Yeah, you can definitely modify it, right? So the way the Pi controlled the DLC32 board and send the it's that it send a couple of coordinates over the time, right? I think it's 15 coordinates a time. So it's not like a CNC file that you have a defined speed upfront, right? You can modify it on the go. So when you change the speed, it won't speed up or slow down. And then you just have to play the remaining coordinate in the buffer until it get to the new speed. But you can almost like change it like instantly.
Right, but when you change after a certain point, does the ball get so much momentum that it is frees itself in the magnet, it sort of goes rolling away, or is it
That
pretty good?
happens, yeah. So I do put like a speed limit on
Max.
the firmware to prevent that from happening. So two things. One is that the ball can move around really fast, and depending on the type of ball that you have, right, you can have like a regular steel ball, um, in which case the magnetic force will not be as strong. But with some of my table, because of the base is very thick, right, and I'm designing around constraint part, which is the Nike table, right. I cannot control the thickness of the base. We would have to use a magnet ball instead. So a magnet ball would have a lot more attraction force. Um, it also means that the ball will just slide around instead of rolling, right? It's just a trade-off of it. But yeah, if you move really fast, it can get lost, or it can fling the sand around and kind of ruin all of the details of the pattern, right?
Right.
Yeah.
What sort of sand do you use?
How much sand? Depending on the table, right? For the smaller one is about 200 gram. I think I don't know how much is that in pound. I mean, uh, about 0.5 pound, right? And then for the bigger, it's about 2.5 to 3 pound of sand.
Okay, so it's a layer about a centimetre deep.
So the depth of it is actually about 25% the height of the ball. That's the recommended. So I
Yes.
use 10 centimeter 10
Millimetre.
millimeter ball. So that would be 2.5 in sand depth.
And what sort of sand is it? I mean, is it play pit sand?
Sorry, I didn't get the question.
The actual type of sand. I mean, you don't go to the seaside and dig it up, I take it.
Not sure I hear it well
Yeah,
enough, but
yeah, the question
yeah.
is what type of sand? Is it like,
Oh
kid
yeah.
play sand, or is it?
No, it has to be a very fine sand. So the problem with coarse sand is that the ball will get tripped up with a bigger grain of sand, and that will create a lot of jerkiness in the motions. So I found that sand that is 80 to 100 mesh works really well. Too fine of a sand, so some people use baking soda, right? But that tends to like clump up together. It can still work, but it will not create like very beautiful patterns. So I found that 80 to 100, 120 mesh work really well. Any more questions from the group?
Yeah, just got three questions if I can.
Yeah.
First of all, the mechanism. You're talking about two coordinates, so obviously the rotation is fairly straightforward, whether it be through gears or whatever. It's fairly simple to give an angle. Okay.
Yeah.
But and the offset, I totally get it. I saw the sliding thing, but can you just explain a little bit more how you're actually doing that so the cables don't get twisted? So how you're actually doing the, let's call it the offset from the center.
Yeah.
That's one question. Another
Okay,
question.
let me answer
Okay.
that. Sorry,
Okay.
first. So with the design, right? There's actually no cable coming up. So you know, with that, I don't really have to worry about you know, the cable being tangled up. Right? I just have two motors like this, and then like this is the gear, bigger gear, and the arm will just slide inside the bit, right? Whereas instead, if I were to mount a motor here on this rotational axis, if I do that, then the two axes will not be coupled anymore, and I solve that problem. But then I will then have the problem of the cable being tangled, right? In that case, you can get around that with what we call a slip ring. It's you know, a kind of rotational device that allow wires to rotate freely around the axis. So that's how you would do it. Yeah.
The second question is, like, if you imagine like let's just call it a virgin table where you've got a layer of sand, and like you were saying, it's about 25% of the ball. Okay. I understand the ball is being driven by the magnet. Totally get that. But I imagine the ball being driven through the sand will create like a valley in effect.
Yeah.
Okay. And will create a mound either side. But some of the images you showed at the beginning was like it was, let's just call it a triangle, but looked like a mound of triangle. How do you get like the raising on one side of the ball and not the other?
So that's actually due to the pattern, right? Let me see if I can share the screen again. Okay, and then go to gallery. I think you were asking about this one in particular, right?
Yeah, like that one where you got obviously a very clear mound, a higher mound on one side, and it's almost, let's say flat on the other.
Yeah. So the trick here is that when the ball, let me actually see if I can pull up this button right on the table, and then explains it. So seeing the actual pattern will make it easier for you to visualize, right? So I think that's one is called my cell. And this is the one. So the trick here is that you know, that I will go back and forth with from the visualizations and the actual photos. The last line in the sand, you know, you will see this kind of really big gap like this.
Yeah.
Right. Anything in between, you can have really fine and intricate details. Right. So this is how it will do the pattern, right? It keep moving back and forth like this. Right. So if I speed this up a little bit, right, it can build out this entire kind of canvas, right, with very fine details, right? But the only final pass of the ball, you will have like a deep kind of two valleys like this. So with that, you know, you can have a really good looking patterns and only have the final lines being a little bit bigger. If that makes sense.
Yes. And the final question, the important one, is your partner still living in the same house, or is she happy now?
Yeah, she's happy. Yeah, she's happy. Although she wants a a bigger one. So
I've heard that one.
kind of,
Okay, no, that's
yeah.
brilliant. Thank you.
No worries. Yeah.
Yes, the previous point on the asymmetry is in fact very authentic because real sand dunes are asymmetric.
Yeah, that's right. That's a good observation. Yeah.
Can you hear me?
Yep.
So my question is more about your approach. You mentioned you were learning things on the fly, and
Yeah.
it's quite a multidisciplinary project.
Yeah.
Was there any tension on wanting to deep dive into every layer of the stack, or and how did you balance just ruthlessly trying to get the project finished?
That's a good question. Yeah. I think for me particularly, my day work, I'm a data consultant. So on the software side of thing, I'm pretty comfortable with it. So when I first started with the project, right, the hardest kind of things to learn is how to design parts in CAD, right? That took a long time for me to pick up. So I spent a significant amount of time there. And I would highly recommend all of you to go and learn that if you haven't done that already, right? Because being able to design anything and then create it within your house, right? It's like a superpower. It's very fulfilling. You can create all sort of stuff. So that's nice. The other part that was really hard for me was learning all of the motion systems and how they work together. As you can imagine, there's not a lot of videos on how this works, so a lot of it is try and error. So my journey was kind of like, okay, for this period of time, I'm focusing on this problem, right? I want to design new products, so I'm focusing on designing it on fast software, or one of my others kind of improvements to the project was that instead of using a 3D printed gear system like this, have a kind of pulley and belt system that will significantly reduce the noise, like mostly eliminate it. And so, with this, there's a lot of try and error. So I have like different period in which I focus on different stuff based on actually my interest, right? And also the community's interest as well. So yeah, it's an ongoing problem, right? But you only have so much time, so you can only focus on certain stuff at a time.
Absolutely, thank you.
Yeah.
Is there anything you learned in specific from the community? Like, is there something the community did that you said, wow, that's a really great idea? Or
Yeah, absolutely. I learned a lot from the community actually. Like very early on, for example, this is the OG, the 3D, the bed right here, right, that I made was a 4-piece 3D printed, just because that this is a 42 centimeter sand bed, and that doesn't fit into a 3D printer, right? So I have to slice it into 4-piece and then assemble it. But by doing that, you create ever so slightly gap between the parts, and with that, it create problem with the motion of the sand. Like when it get to the seam, it will trip up or something like that. So it took a lot of sanding as well to get it to even. So it was a pain to solve. Some of the idea from the community is that why don't you use an IKEA tray for it, right? So this is what I came up with, designed around it, and that was a brilliant idea that kind of kickstart and got me thinking. Instead of just doing like standalone versions like this, why don't I just design a full-on products on an IKEA table, and that's actually led me here. I can go on and on about the different stuff that I learned from the community, but people share a lot of cool ideas. Like many of the software features that you see that I've shown, It's from the community request, right? Some people will be like, okay, I'm gifting this to my family, for example, and they have no technical skills whatsoever. How do they set up a Raspberry Pi? How do they SSH into a Pi? and so, you know, I kind of made the installation progress really easy. I made it so that they can set it up, and then like any other devices, right, you can have a Wi-Fi hotspot that you can join. And then from there, you can select the network that you want to connect to, and you know, all of that experience is a lot more intuitive than SSHing into a Pi.
So one thing I didn't quite understand is how does it clear the image? Like, how do you start like a brand new image? Does it just?
Oh yeah, there are different clear patterns actually. So you know, you just do something very, very basic like this. So this is a spiral image that will just go on and on. And then that will clear the canvas. You have a sideway pattern that you can clear as well. In some contexts, you can do what is shown in the image, right? Whereas this one, the clear patterns, the one in the background is actually another pattern, right? And then I started another pattern on top of it. So you can be creative with it.
Have you thought of bringing in like real life status, so you show what the weather is that day or something like that?
Yeah,
Clouds.
it's actually quite a common request, right? Is to create a clock, right, or something like that, something like
Oh, yeah.
displaying
That's
a
good.
status. Yeah, I haven't got around to doing that though. Although it's would not be too hard to do.
Yeah. No, clock's a really good idea because it's the right shape and everything, isn't it? So you can
Yeah.
change it.
So you know, you had this website right here, because the patterns are generally it's kind of hard to make right now, right? And that's is something that I may work on next. But so the pattern is hard to make because mainly because it has to be a single continuous line, right? And most of the graphics out there is SVG, right? And then, you know, in 3D printing or in laser cutting, you have a lot of SVGs fine, but they are not single line, right? They have different, let's say, island, right? And then with the sand table, we cannot jump from one to another. We cannot lift the ball off the table. So, you know, creating beautiful patterns is hard, right? So there are some software out there like Sandify, for example, that make it easier for us to just generate patterns. So you can, so with this software, for example, you can start with like a shape like this and then apply an effect to it. Let's say move and refine, right? And then, no, let's try something else. Like a warp effect, for example. Yeah, and just keep on repeating it, for example, and then you can create a pattern, or you can type in a text like this, right? And it will just draw it out. So this is one way. The other way, which you know, requires a little bit of an art skill that I'm not able to do that yet, is some approach like a company like Ground Labs, right? They have amazing patterns. What they do, I think, I believe, is that they hire artists to go and draw single line digitally, right? Draw single line patterns like this, and then you know, they convert that into the coordinates of the system, so they can create beautiful stuff like this, right? But unfortunately, they keep their patterns to themselves. So you kind of have to get the table to get this. Yeah.
Wow. And have you heard from the original makers, the guys that originally designed the similar table? I forgot what their names are.
Bruce, no, I have not.
Yeah, just wonder if they want to use some of your patterns, because they sort of like have a community building all these patterns. Maybe they
Yeah.
want those patterns for their own. I don't know.
Yeah, that'd be
It's quite
cool.
interesting.
Yeah.
I think the community idea is really great, where you sort of like have this whole community of building different patterns and improving the devices and things like that. I think it's a really good idea.
Yeah, I launched like a mod hub recently, right? So people just have different ideas for their table, and they have kind of been contributing to the build, right? And creating different versions of it, and I think that's very nice. Yeah.
That sounds like a lot of fun.
Yeah.
Cool. Thank you very much. Any other questions from anyone? Anyone online?
I have asked in the comments section, have you thought of adding a joystick to it so people can do their own pictures?
Yeah, I
Very
actually, I actually tried it. Not with joystick, but like by a program to do it with a keyboard, right? With the arrow buttons. It's harder to control, right? It's not intuitive just because of the way the table is, right? It's a two axis like this, so when it's harder to control, let's say that.
Yeah.
So I decided not to promote that feature, but it has come across my radar. Yeah, if it's like kind of like a Cartesian plane, then it's more intuitive to control. Like you up is up, down is down, but then now you have two independent motions, and then there's an offset as well. So it was quite hard to control it. Yeah.
It would be a challenge.
Yeah.
So what's your next project then? So you've done this, it's very popular, and you've had a lot of fun. Do you have something else in mind you're going to build now, or you content with
Yeah,
it?
I'm actually like I'm not done with this, right? So my next idea is to build it into something like this. It's a little bit bigger, so it's gonna be more challenging. This is the one that I'm looking to do.
Oh, wow.
So this is a very beautiful coffee table, right? It's also quite big. I think it's 98 or 88 or something. What is the diameter of this one? Measurements. I can't remember, but around that. So yeah, it will be a 97. There you go. It will be a fun project to work on this. I also recently got into woodworking as well. So got a CNC machine and all of the stuff. So been making some furnitures and stuff around the house. So it's just fun.
I just wonder if you should contact IKEA and offer to build them some. Sure.
Yeah, probably too small of a fish to do that, but yeah.
Very good. It's very interesting. Thanks very much for that talk. It's really good. Thanks for taking time out of your day. It's the middle of your
Yeah.
day there, so it's a big ask. I certainly appreciate your openness, and I think it's a really good project. It's very interesting. You can tell from the questions you got, everyone's quite keen to build their own, I think.
Yeah, absolutely. Let me know if we have a Discord channel, so if you are interested in building one, we'd love to see you there. Thank you for having me. I hope to attend one of these in person someday.
Thanks very much.
All right. Thank you, everyone. Have a good day.
Very good.
Bye.